In this last set of lessons here, what we're going to do is look at ways to combine radical expressions. That's things with square roots. And in this video, we're going to look at how to add those and how to multiply things with square roots. In the next video, in the final video, we're going to look at how to divide things with square roots. Starting with the easiest, when we're adding or subtracting radical expressions, that's things with square roots, you just combine them if they're like terms, right? This is the same idea as if I had 3x plus 7x equals 10x. If I have 3 square root x plus 7 square root x, I have 10 square root x. Now, what matters is that they do have the same index. That's the little number up here. If those numbers match, we can add them, and they have to have the same radicand. That's the number in here. If those things match, we have the same exact items, a square root of x and a square root of x, then we can combine them because we have 3 of some type of thing plus 7 of some type of thing. We just get 10 of the same type of thing. Here are some examples. Notice that here I have a cube root of AB, a cube root of AB, and a cube root of AB. They all have the same index. They all have the same radicand, so negative 2 of that plus 7 of that minus 1 of that same thing would equal 4 of the same type of item. It's like I'm saying I have negative 2 bananas plus 7 bananas minus 1 bananas equals 4 bananas. This is just a type of thing, and I'm going to have more or fewer of them in the end. The same thing here, I have x cubed root 3y, x cubed root 3y. These are like terms because they have the same items. They both have an x, they both have a square root of 3y. So we can combine them. 1/4 minus 3 halves. You can use your calculator here. 1/4 minus 3 halves, and we get negative 5 over 4. Negative 5 over 4 of the same type of thing, x square root 3y. So when adding and subtracting, all we're doing is treating as if we're combining like terms. If they don't look like terms, so in this example, I have a square root of 8 and a square root of 2. Those are not alike. You're going to do your best to get them to be alike. So in this example, 3 square root of 8 plus square root 2. Is there a way to get them to be alike? Well, maybe I can simplify this radical. 8 is 4 and 2. 4 is 2 and 2. The way we did this when we were simplifying radicals, that's 2, 2, and 2, and we're looking for buddies. So I'm going to bring down the things that I have on the outside already. That's a 3. There's no way to simplify that square root of 2. And this gives me 2 square root of 2. So what I'm saying here is that the square root of 8 is the same thing as 2 square root of 2. If we simplify the square root of 8, it simplifies into 2 square root 2. 3 times 2 square root 2 makes 6 square root 2. And now, check this out. We have like terms. 6 square root 2 plus 1 square root 2 makes 7 square root 2. The next one gets a little bit more complicated. And you can see that final one gets even more complicated. So B. Again, I'm just going to rewrite my problem over here. 8 square root x cubed y squared minus 3y square root x cubed. They're not like terms because the radicands do not match. But can we get them to be the same? This is x, 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 y, y. And look, we've got buddies and buddies. So this is the same thing as, I'm going to bring down my 8. That's x, y, square root x. Notice the x, the buddies get to go outside. Buddies get to go outside. This guy's left alone. He has to stay inside. If you need to go back and review the video on simplifying radicals, you should absolutely do so. All right, the minus 3y comes down. X cubed is x, x, x. Look for buddies. The buddies get to go outside. People without buddies have to stay inside. And now look what I have. 8xy square root x minus 3yx square root x. They are like terms, even though they're in the different order. Xy square root x, yx square root x, it's the same thing. 8 of them minus 3 of them leaves you with a total of 5 of the same type of thing. X, y, square root x. I could have written yx square root x. I'm going alphabetical order here. Take a second. When you get ready to unfreeze the video, I'm going to show you how I simplified each square root. This is how those are simplified. And so that's square root 50 x squared y to the fifth. Look here, I have buddies, 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 buddies. So I have 5x y squared. And without buddies, I still have a 2 and a y. I need to bring down this negative 13y. And here I have a 2. No, that 2 doesn't have a buddy. I'm sorry. I have buddies, buddies. Y, x, square root 2y. All right, now I need to bring down this plus x, y. This is the biggest mistake people make, is not bringing down these items. So plus x, y. We got buddies. So there's a y. Buddies, there's a 7. And what's left over is a 2 and a y. All right, let's see what we can do with this. That first item, there's no way to simplify it at all. 5x squared y, square root 2y. Here, 13x and 2y's together make y squared. And here, x, 2y's, and a 7, so that's 7xy squared, square root 2y. Now look at what we have. We have x squared y, xy squared. Ooh. We have an x squared y, we have an xy squared, and we have an xy squared. You see that? So these guys actually can combine. These have the same thing. This one right here does not have the same items. It has an x squared y. Oh, I just wrote that incorrectly. It's supposed to be xy squared. That's my bad. So look here. This was xy squared. When I translated it down, I just wrote it incorrectly. Xy squared. They all have an xy squared. 5 of those, plus 7 of those, minus 13 of those, gives you a total of negative 1 xy squared, square root 2y. They all have the same type of thing, so we can combine them into one term. All right, when you're multiplying radicals, so that was all addition of radicals. When you're multiplying radicals, what you're going to do is multiply the outside by the outside, multiply the inside by the inside. The outside stays outside, the inside stays inside. So on this first example, 3 square root 2 times 5 square root 6, outside times outside, 3 times 5 is 15. Inside times inside, 2 times 6 is 12. And then we want to simplify this if we can. 12 is 3 times 4. 4 is 2 times 2. 2, 2, 3. We got buddies. Again, we have to bring down the 15 times 2, square root 3. The 3 was the only thing that did not have a buddy. 15 times 2 is 30, square root 3. That's our answer. All right, the next one, outside times outside. 2x times negative 7 is negative 14x. Inside times inside. X times y would be xy squared. Simplify the inside if you can. That'd be x, y, y. I'll have some buddies. That's good news. Negative 14x. I'm bringing this down. The y gets to come outside. The x has to stay inside. And that's my answer. So with addition, you have to have like terms. Notice that with multiplication, you don't have to have like terms. You can multiply any radical times any radical. What you're going to do is the outside times the outside and the inside times the inside. If we have to multiply an expression, so here we have a monomial and a binomial. We have two things that we have to multiply to. We just treat them like they're variables. You're just going to distribute. So I'm going to distribute the thing that's on the outside, the entire thing. Distribute it to the 2. Gives me 6 square root 11. Remember, outside times outside. Distribute it to that. Gives me 3 square root 121. Inside times inside. Square root of 121. 121 is 11 and 11, which are buddies. So that's 6 square root of 11 plus 3 times 11. That's 6 square root 11 plus 33. When multiplying, especially multiplying and dividing, you always want to check when you get to the end of your problem to make sure there's not one more step that you can do to simplify. That's how, when I got to this step, I was just looking around. I said, well, that 121 can probably break up into pieces. All right, we'll do this first one together, and then I'm going to let you try the second one. So binomial by binomial, we're going to have to FOIL or distribute, whichever way you prefer to think about it. So square root of 5 times 2 square root of 5. That gives us 2 square root 25. Outside times outside, inside times inside. Square root 5 times square root 2 gives us square root 10. I kept a negative sign because there was a negative there. 3 square root 2 times 2 square root 5. Outside times outside gives you 6. Inside times inside gives you square root of 10. And 3 square root of 2 times negative square root of 2 gives you negative 3 square root of 4. The square root of 25, I know, is just 5. Those two are the same. So that will give me, actually, let's just leave that there for a step. We'll combine all our like terms in the next step. Square root 10 plus 6 square root 10. The square root of 4, I know, is 2. All right, 2 times 5 is 10. And 3 times 2 is 6. All right, now we can combine like terms. 10 minus 6 is 4. And negative square root of 10 plus 6 square root of 10 gives you 5 square root of 10. That's going to be your final answer. Take a second on the next one and try and distribute. So here's what happens when you FOIL. Here, I'll draw these arrows at the time when I'm foiling here so that you can see where they came from. This times that gives you this item. This times this gives you that item. 7b times the first gives you that. And 7b times 2b gives you, that should actually be 14b squared. All right, I'll have to adjust that as we go. In the next step, we're looking for items that we can fix. So that square root of b squared is the same thing as b. You can break it down, it's b and b, right? b and b, those are buddies, so they get to come out. And again, this should be 14b squared on the end. And then we can combine like terms. Notice those two items in the middle are like terms. Negative 20 plus 7 gives you negative 13. All right, radicals and exponents with the same index are inverse operations. So we saw here, for example, that this square root of b squared just turns into b, right? This is the same idea. A square root of 2 squared just turns into 2. 4 is 2 squared. The square root of y squared will just turn into y, okay? Technically, we should remember, back from a couple lessons ago, technically this is absolute value of y. But for now, we're going to let that slide. We're just going to say that these variables are positive, and so we don't have to deal with the absolute value sign. All right, so a square root, that's an understood 2 index. A square root of 11 squared is just 11. A fifth root of z to the fifth is just z, and a cube root of pq to the third is just pq. This is getting that idea that radicals with the same index as the exponents, right? It's an understood 2, that 5 matches the 5, the 3 matches the 3. As long as the index of the radical matches the exponent, then those are inverse operations. They just undo each other. All right, when we want, this is the toughest part of this unit, of this lesson. When we want to multiply, right, we're talking about multiplying. Squaring is just multiplying by something by itself twice. So when we want to square a binomial that has a radical, what we're going to have to do is write it out twice. Square root d plus 3 times square root d plus 3. Same thing as saying 5 squared is 5 times 5, right? We're using that same idea. 5 squared, 5 times 5. Square root d plus 3 squared is the same as square root d plus 3 times square root d plus 3. And then we're going to have to FOIL just like we were doing a second ago. So first times first, square root d is square root d squared. Square root d times 3 is 3 square root d. 3 times square root d is 3 square root d. 3 times 3 is 9. The square root d squared we just saw on that last slide. Same index as a radical. Square root d squared is just d. Those two will combine into 6 square root d, and the 9 will just come down. We don't have anything else that we can combine here. Try this next one. I'm going to show you my answers in 3, 2, 1. So write it out twice. Distribute. Combine like terms. Multiplying by conjugates, so this looks a lot like what we had in the last slide. When you multiply by conjugates, something special is going to happen. This is the last slide of this video. This slide is an important one to remember because this idea is going to come back to us when we talk about dividing in the next video. All right, multiplying by conjugates. What a conjugate is, these look the exact same. These two parentheses look the exact same. The only thing that's different is this one has a plus and that one has a minus in the middle. Those are called conjugates, right? It looks like a difference of squares. It looks like when you were factoring and you got a difference of squares. Same thing in both parentheses, just one has a plus and one has a minus. We're going to multiply these and see what happens, but something special is going to happen here. Square root 3 times square root 3 is square root 9. Square root 3 times negative square root 2 is negative 2 square root 3. Remember, outside times outside, inside times inside. Positive 2 square root 3, and 2 times 2 is negative 4. All right, the square root of 9 is 3. These two items, notice that they're the same exact thing but opposite. We have a positive 2 square root of 3 and a negative 2 square root of 3. If I add those together, I will get 0 square root of 3. So those items, actually, the middle items, cancel out. And that will happen every time you're multiplying conjugates. Every time you're multiplying conjugates, those middle items will cancel out. And then 3 minus 4 gives you negative 1. And now notice what we have. We multiplied things with radicals. We multiplied things with square roots. And we ended up with a rational number. We ended up with something with no square roots. We need to remember, again, remember this, because when we get to dividing, we're going to use this as a trick to rationalize fractions that have square roots in the bottom. All right, that's the end of this video. See you in the next one.